comes with a variety of experience in FMCG companies. He's worked in Unilever, Procter & Gamble, and now Coca-Cola. Please welcome Damodar Hegde from Head of Manufacturing Excellence, Bottling Investment Group, Coca-Cola. Damodar, over to you.
Thank you, Vikram. Thank you. Perfect. Merci. So, thanks for having me here. It's not just Vikram whom I have to thank. I also have to thank Bob and Fox because they were kind enough to me. I was on holiday till yesterday, so they put me on a slot where my jet lag was mostly gone. Otherwise, in the morning, you would have seen me chugging only coffee and Coke. And I'm going to pass that kindness on to you by saving us some time and getting you to dinner on time. That's the promise I made to Vikram. So we are going to not get into any very theoretical stuff. I think all the technology bits you can hear about IT, OT, about different layers of software and different layers of hardware we have already seen today. In Coke, we do something far more simple. We refresh people, and we try to make a difference. That's the byline you hear from Atlanta a lot nowadays. And one of the things we will try to visit today is, and I think that question came up from one of the tables earlier, right? You had raised that, is smart always more sustainable? And the answer is not necessarily. But doing it is right is what is important. The intent should be there, the North Star, the compass should be very clear. Then you can make smart manufacturing more sustainable. The other way around, without going smart, sustainable is not going to be possible at all. But let's roll back a little bit into history. Let's go back in time a bit. I'll take you along to get into what Coke understands under sustainable manufacturing to a non-Coke example of a person who in 2005 spent little under 72 days traveling around the world on just a catamaran. That means she was basically sailing around, and she had to take enough food and survival stuff along to be able to make those days count, because she couldn't have a stop and have somebody helicopter in food. That's very comparable to our life journeys, and that's one of the things that Coca-Cola is beginning to wake up and realize. We were talking earlier about our plastic bottles and how one of the most core parts of a bottle of Coke is the water in it and the container it is in. And we are also beginning to realize that that is actually a finite resource. We cannot continue to produce more plastics, assuming that somebody else is going to pick it up and recycle it for us. We are beginning to own that. And we had to look for a paradigm. We had to look for a model that allows us to work around it, that allows us to set targets, that let us measure whether we are able to do well while doing good. Right? And for that, we choose what is currently known as the circular economy model. It's mostly attributed to Ellen MacArthur Foundation. And she started working on that after realizing that those 72 days she spent on the sea, the last few days were the most toughest ones. And she extrapolated that and said, if people were to live 70 to 80 years, and our generations were to live 3-4 generations from today, does our planet have enough resources? We are not going to get any support brought in. We are not going to be able to just migrate out to Mars. There is no simple solution to that. So can we make what we have last longer? Can we recycle? Can we reuse? And much of that work has flown into the supply chain. So it's in 2023, the Association of Supply Chain Management released what is their new supply chain operations reference model. And that's also based on the circular economy principles. So I hope there are no questions to this, but we can, of course, pick that up. I'll share the notes with ARC, so you should be able to get the connections to be able to understand what does Coke use to understand their supply chain, right? We no longer talk about manufacturing anymore. We talk about transforming raw materials, whether it is plastic pellets, whether it is glass bottles, into a product it could be a subscription for a freestyle machine. So when you go to a Burger King or to a McDonald's, you basically take a glass. You can take your own glass and basically pour out your own drink. But we also have bottles that get sent to your home by Lazada, and our intention is to collect it. So in Singapore, we soon will be next year working together with the government, looking forward to introduce deposit return schemes, which will allow us to incentivize getting those containers back so that we can recycle them, right? And that means you end up breaking down that process, and many of you had that thing already. If you want to improve something, you need to be able to measure it. If you want to measure it, you need to be able to work on it, and that's where it comes in. At what point do you start measuring electronically? What point do you automate? At what point is it enough to have a rough direction? So we did some broad strokes. So we had to kind of look at where do we want to go. So we already have a 2050 target. I won't be able to comment on it today. Our last publicly available target is the science-based targets that we want to achieve by 2030, where we want to reduce the amount of carbon emissions we have. We are not yet going to net zero in 2030. That is the intention for 2050. You will hear of those plans when it's released. But the current intention is, can we increase our recollection rates? Can we reduce the amount of plastic required to get our product to the consumer? And can we reduce the amount of energy, the kilojoules required to get one serving of Coke? So we talk about 250 ml of Coke, and it may be Coke Zero. But how many kilojoules are required to get one serving of that into a consumer's hands? That includes, if you're taking it from a Burger King, it includes the paper cup. If you're taking it from a glass bottle, it includes how much washing powder went into washing that bottle, making it available, and getting that empty bottle back into a factory. And if you're looking at a plastic bottle, it includes the amount of energy spent to recycle that and the percentage of virgin PET we had to add to make sure that that bottle remains transparent, right? So we are building that energy model to be able to understand how can we reduce the energy consumed. The other part I had mentioned in the beginning is the amount of water consumed. So whether it is for washing the glass bottles, whether it is for making the drink, or whether it is for making sure that if people are not drinking out the bottle and pouring the product out, how much chemical oxygen demand does that produce? Where does that go? How does that impact the community we're working in? So the bottle of the future, as I said, the packaging goals are we try and recycle 100% of what we sell. We get all that plastic back. It means sometimes taking other people's bottles in and reusing them. But the key bit is we are also working at newer technologies. So many of our products, so if you go to Hungary, if you buy non-carbonated products, so without soda, if you look at milk products, for example, soya milk product, Ades, etc., they're already available in paper bottles. And again, there also we measure the amount of energy required to replant that tree and to get that tree into a paper bottle, how much energy went into it. And that's the real comparison. It's not is glass or paper or plastic better. It's how many megawatt hours did it take to get 1 million bottles out in a day out of a factory. And that's the key metric we're looking at. And again, that's something that, as I said, was all broad strokes. But we're coming back to our original question about where does smart pay off? What does happen is if you want to understand how much energy is being consumed in a factory, and I think Andy already covered all bases for me, so I'm going to save some time there. You need to measure not just how much you're paying every month on your power meter. You want to be able to measure how much energy are your compressors eating up. How much energy is your blower eating up? How much energy is getting into the filler? Every time you have pipelines full of Coke and then you need to wash it down, how much water is getting used there? You want to break it down as much as possible, but you don't want to spend power in order to measure it all the time. So often what we do is we take meters and shift them. We create a mathematical model, and then we remove the sensor and put it somewhere else. So that once we have a model, we can go back to just doing sampling, just like we do in a laboratory. We don't take every single bottle and test it for pH. Instead, we take a certain number of samples. In a similar way, we try to do our models of how our manufacturing works and measure it during different SKUs, different runs, different external temperatures, et cetera, to say, okay, this is how much energy we are consuming, and does that tally with the monthly bill we are paying, if it's for water, if it's for power, et cetera. So that's how we start getting smart in our manufacturing areas. What it's also helping us do is the cost of sensors, they have been going down for the last 3-4 decades. I mean, if you had tried to do what Hexagon does today, about 30 years ago, the only industry that could afford it was airline industry. And earlier, me and Cedric were talking, this is becoming more and more because people are able to build smart sensors at home because you can get them for a couple of dollars now. If you're buying them in bulk, maybe a couple tens of dollars if you want to buy them at home, whether it's temperature sensors for your garden, whether it is a sensor for your fridge or for your air conditioning. Those things are becoming ubiquitous. They're more available at much lower rates. That also means we are able to measure stuff like groundwater levels. So 10 years ago, when I first ran my first plant for water filling for Coke in Munich, we used to do manual readings of the groundwater tables. Today, it's electronically submitted. Every minute, we get a reading of how much water has been taken out. If there's rainfall, how long does it take water to go from the rainfall tanks into the ground? So those things are measurable, and the more you can measure it, the better you can model and understand the physical phenomena behind it, and therefore you can recalibrate your drivers to hit those sustainability targets. So without measurement, improvement becomes difficult. It's like having a car. If you don't see the RPM meter, you don't know when you need to shift your gear. On the other hand, I go back to that principle, you don't want to become too smart. There's no point in having an RPM meter on your bicycle. It's overkill. So you take a dashboard out of a Porsche or an Audi and put that on a bicycle. You can do it. It's possible. It'll be expensive. It'll make you heavy. But it probably doesn't serve the purpose. So that's the kind of pragmatic way of work we try to walk along in Coke. And that also means that we are also looking at artificial intelligence, but not within our factory limits. I showed you the whole transformation diagram where we are working on the whole supply chain model. So the example we look at is, as said it earlier also, we are looking at deposit return scheme in Singapore, and we would look to make that digital, which means we already have models. This, for example, is in Vodafone. They have excess capacity on their 5G network. So Vodafone has built a lot of capacity, and they realize the population is shrinking, so they don't have consumers who will use the 5G bandwidth. So what are they doing? They're coming to industry and saying, if you have any needs, we'll solve them. And what are we doing? In Germany, it's common that you take your empty bottles and give it back in a reverse vending machine. And we are making them smart. The reverse vending machines are sending to us and other manufacturers when bottles have been returned. That means as a factory, I already know that my empty bottles are coming back. If it's plastic, it needs to go through recycling. If it's glass, it's going to come back to me. What bottles have been returned in what postcodes at what days. This is not only helping us see what empties are coming back and where do I have to buy new bottles, it also helps us to understand where is actual consumption happening. So if there's a Taylor Swift event, you know that the couple of markets around them, you see a lot of empties coming back, you know that people were drinking whole bottles. So next time you know it, you probably want to have enough stock when something like that happens. This is information we didn't know before, because what would happen is you would have people buying stock, but you didn't know how much of it went into a cellar somewhere and how much of it was actually consumed. By looking at the empty bottles coming back, we have that data. Second, this also helps us understand how much of those bottles are actually coming back to us and how much of them are getting lost somewhere in the sea. We would have a better tracking of where that plastic is going. And in Europe, this has been in work for about 2 years now. They have started making the caps attached to the bottles because they realize that people bring back the bottles, but because we don't measure whether the caps have come back or not, we lose about 2% of the plastics. It goes into landfill again, something we are trying to avoid. So if you go to Europe, you open a water bottle or a Coke bottle, you'll see the caps are connected to it. So it also helps you get enough data to work with the governments on regulation. And then this is how we use machine learning. So when the consumers give back those bottles, not only we look at single bottles, we also look at them in a crate, and we use ML to generate fake figures of how different bottles would look like under different lighting conditions. And then after a certain number of iterations, we are able to identify the bottles. So we get beer bottles sometimes in our Coke crates, and that's okay. The whole intention is get that information early to the beer bottling manufacturer so that they can tell us, Coke, you got some bottles in your crates from us, we'll come and pick them up. Not having that information in the past meant we ended up with inventory of other bottles that we had to actually tell them and say, we have a truckload of stuff, can you come and pick it up? They might have needed half a truckload 3 days ago, but they couldn't produce, they had to buy new bottles. So that kind of stuff gets solved. So when you think about, is AI going to change everything? The answer is not immediately, but eventually it's going to have a huge effect. In the past, when we wanted to do something like this, it would make months of counting and filling out Excel sheets. Now this happens automatically at the point in time where the customer is already giving back the bottle. Used to happen in factories in the past. So that's how AI is also impacting manufacturing. And then our intention is long-term to be able to go back to the consumer and be able to give every consumer a score that says you have separated your bottles well. You have been able to consume so much, but you're also doing this part in your environmental impact. This is the amount of kilojoules you used up to refresh yourself, whether it is water, whether it's alcoholic beverages, whether it is soda. We want to be able to give that transparency to our consumers so they can make informed choices of why they want to prefer containers, why they want to prefer certain beverages, and why they want to change their habits around consumption, right? So that's almost the end of the presentation. I think I give you back 6 minutes. We intend to take the questions in the panel, but if there are any burning questions, I can give us a minute. Vikram.